Hello, my name's Phil Selwyn, Technical Director and Founder of Water Power Technologies. We're here today to talk about the Seradisc filter system, which is something that we developed about 7 or 8 years ago to overcome problems that we had with filtration on our water-powered pumping systems. Later on we'll be looking at a test we've rigged up to show you how effective the Seradisc is, but I'll just say a few words about how the filter actually works. It's basically a series of flexible discs with integral springs on them, which allow the spacing between the discs to vary depending on how many discs are assembled on the barrel. So as you can see here, there's 8 discs there already assembled, but we can just keep adding more until we reach the number that we require to operate. So this just fits on here with a nut on the end, and then that completes the filter, and you can configure it in a number of different ways. As you see here, we've got floating ones, so these are fitted to a manifold with floats attached to the guard, so you can put as many different configurations as you want and they'll float underneath the water level. And if you need them to float further underneath the water level than just one float, you can also put an extension rod so they'll float lower down below, so that saves you picking up any debris from the top or crust from the bottom. But again, depending on the weight of the different manifolds you might use, so for instance here we've got a bigger metal one, that's a 10 Seradisc system, and obviously because it's a bit heavy you may have to use sort of bigger ball floats which are easily available from your local pump suppliers, and you just configure the manifold and float to the application you want to use it for. The extra discs are available in additional packs of 16. So there's your standard filter with full instructions on it, giving you the different applications. And inside you get various couplings, including a rubber one with stainless steel clips. So it's fairly universal. You can fit it to most systems. It's got a BSP thread, but again, with the rubber coupling, it means you can adapt it to most things, and if you need to put it onto an NPT or metric thread, then you can just get an adapter to fit as a standard. We want to actually show you how good the Seradisc is in comparison to the conventional can filters. So what we've got here is a tank, see-through tank. We've got glass sides so we can film it quite easily. We've got a high volume recirculation pump in the bottom. So what we're actually doing here is we're putting water through the filters, 3 of them. We've got 2 can ones, plastic one, steel one, and our Seradisc filter. And what we're going to show you is how quickly the conventional filters block up in comparison to the Seradisc. So it's not fixed, there's no tricks, but unfortunately, when we film it, it's filmed over a period of time. So what we'll have to do is sort of splice and cut, but it'll be quite obvious from the first film how quickly the others block compared to the Seradisc, and over the period of 20 minutes we'll actually show you the filters completely block him and the Seradisc keep running. But the important thing to remember about this test, which we'll try and identify in the video, is that it's the amount of volume of water that's flowing through the system. So whilst the can filters appear to be flowing for quite a long time, the actual amount of water that's flowing through them is relatively small. But we'll put some figures to that at the end of the video anyway and just explain that. So walking around to the front of the tank, what we've got inside are the 3 filters. We've got the plastic can filter, we've got the metal can filter, and we've got the Seradisc filter. So basically the experiment consists of a water tank, which is quite a big volume one, so we can get as much debris in as possible to show you how effective this is. So we've got a recirculation pump, as I said before, which recirculates the water to the top. The water's falling through all 3 filters, where it comes through the tubes into a trough at the bottom, which you can just see here. So at the moment, because there's no debris in the tank, all these 3 tubes are running exactly the same amount of water. So what we'll do, we'll film this separately, and you'll see that as the filters block up, you'll see how these flows gradually decrease. Right, so I'm going to throw some fairly coarse, clean sawdust into the tank and mix it all up, and you'll see as it starts to circulate, it'll start sticking to the filters. I won't put too much in, because if you put too much in, you've got a job to film through it. So I'll just put a couple of handfuls in, mix it all up, and see what happens. Now, hopefully, you should be seeing that the little filters, the plastic and the metal ones, are already starting to block, as the Seradisc is still clear. So what I'm going to do, I'm going to clean these off with my hand. And I think you'll see how quickly they gather debris again. Yep. So the middle ones, the can one's already getting a load more debris around it, and it's only been, what, 10 seconds since I cleaned it? And the same with the plastic one on this end. Whereas the Seradisc is still relatively clear. But again, the can filters are blocked up already. So they're blocking up in about sort of 10-15 seconds. Whereas the Seradisc, as you can see, is still really clear. So you can see now from this angle that there's more and more debris now building up on the Seradisc at the back, and that's because the can filters are almost completely blocked. But you can see how there's still quite a lot of blue area on the Seradisc, and I think it's point made, really. You can see the streams. You can definitely see the streams on the middle and the left-hand side now are getting much less. Whereas the Seradisc one's going great guns. There we go. The plastic one's now stopped, blocked, and you can see the air bubbles coming up, which basically means that it's so restricted that the vacuum and the middle one started as well. That's interesting. So those two have almost blocked at the same time. But you'll notice the Seradisc on the right hand side is still flowing at full rate. So you can see now how much the Seradisc is still running. This is about, what are we, an hour and 20 minutes running. So we'll just have a look at the filter itself to see how much debris we've got on that. And I just want to show you one of the other tricks that we do with the Seradisc just to prevent full blockage, because there's a lot of pumps. If you run them dry, it's a very expensive process to replace the parts or the whole pump. So we've got a safety feature on the Seradisc, which I'll just show you in a minute. So the other feature, the safety feature on the Seradisc filter, is one which allows pumps to not run dry. So what happens is when the filter gets blocked, and although it's not completely blocked now, you'll see that it's building up quite a bit of debris on the outside. But as this gets completely blocked, what happens is it draws the plates together, which then causes the top disc to pull down, and it exposes a small orifice here, which just allows enough water to go through to keep the pump system from running dry. So that's a safety feature, but you mustn't allow them to run for too long like that, because obviously it has a tendency, as you'll see there, to draw in debris through the holes. But certainly with things like mono pumps, it can be the difference between saving the pump and the pump becoming obsolete, or at least needing a lot of expensive repairs. So that's the safety feature there. Thank you very much for watching this successful demonstration today. We obviously don't need convincing, because we've been fitting them to our pumps now for 7 or 8 years without a single hitch. So if you would like to find more information, please look at our website, which is Seradisc, www.seradisc.com, and you'll be able to find more information from there. Thank you very much.